This video will elaborate how to compute scalar products of vector, especially involving unit vector I, j, and k. Remember, in the coordinate system we have x, y, z axis. Now the unit vector I is a vector of length 1 parallel to the x-axis, and unit vector j is a vector of length 1 parallel to the y-axis, and the unit vector k is a vector of length 1 parallel to the z-axis. We know that A dot A is equal to magnitude of A times magnitude of A times cosine 0, since the angle between A and A is 0, and cosine 0 is 1. So this is the magnitude of A squared. As we know that the vector I, j, k are perpendicular to each other. For example, I and k are perpendicular to each other, j and k are perpendicular to each other, I and j are perpendicular to each other. So we expect if they are perpendicular to each other, I dot j, j dot k, and k dot I will be 0. On the other hand, since I and j are unit vector, so the length of I is 1. Right? The length of j also 1, the length of k also 1. So when you square, the length will be 1. So we have I dot I equal to 1, j dot j equal to 1, and k dot k equal to 1. Now how do we use it for vector in terms of I, j, k now? So if A equal to A1i plus A2j plus A3k, B equal to B1i plus B2j plus B3k, then when they do a dot product, we can do the distributive law. That means that we can take A1i dot with B1i, B2j, B3k, and A2j dot with B1i, B2j, B3k, and A3k dot with B1i, B2j, B3k. So this is actually the distributive law. Now as we do a distribution, we know that I dot j is equal to 0, I dot k is equal to 0, and so you only have A1 and B1 in the first term. We also know that j dot I is equal to 0, and j dot k is equal to 0. So we only have A2, B2 in the second term. And we also know that k dot I is equal to 0, and k dot j is equal to 0. So you only have A3, B3 left in the third term. So in conclusion, if you're going to do a dot product in terms of I, j, k, there's a very simple way to do this. A dot b will be just A1, B1 plus A2, B2 plus A3, B3.